and welcome to another episode of The Matters That Matter. Today's matter that matters is a very vital one. I'm joined today by Professor Ferrytell, whose incredible new discovery is sending shockwaves throughout the medical establishment. Now, Professor, thank you, first of all, for joining me today and agreeing to this conversation.
Not at all. I appreciate the chance to speak.
Now, you are the head of the infectious disease department at the University of Plymouth.
Yes, that is correct.
And you used to be head of virology, but you resigned from that post, becoming instead founder member of the fledgling Spacebadgerology department.
Yes, I was not ashamed to admit my mistake. The new department was necessary to spread the awareness of my breakthrough, the discovery of the true mechanism behind all disease.
Well, let's get straight to it. Now, you claim you have just isolated the space badger responsible for measles.
The space badgers are just the pilots. It's the measles spaceship I have discovered and isolated.
That's, fantastic. How did you come across these extraordinary pathogens?
Well, the isolation was the fundamental breakthrough.
Can you take us through the isolation process?
Yes, of course. Well, the first thing is to take some gloop from someone who was full of space badgers. We collected from the nose or throat, and we added to...
Sorry to interrupt. When you say you take the gloop from someone who's full of space badgers, how do you know the person is full of space badgers?
There could be many signs. It could be a cough, a runny nose, itchy eyes, loss of smell.
I'm sorry, I'm not clear. I still don't see... How does this mean they're definitely full of space badgers?
But this is what illness is. It means your body is being attacked by an invading space badger fleet.
But I thought this experiment is supposed to be how you show that space badgers exist.
If you'll just become patient, or will become...
Yes, but I don't understand the first step. From where did you even come up with the notion of space...
Look! When I was invited on here to tell you the facts, I didn't expect to face some kind of science denialism. I'm the head of an infectious diseases department. How could I possibly be talking nonsense? Let me finish, and I'm sure you'll understand. Okay, we take the gloop from someone full of space badgers, and we add it to a very special dish of stuff.
Can't you just look at the gloop straight away with electron microscopes and see the space badger?
No. Seeing the space badger ship in vivo just doesn't happen. Never has. No, we have to use secondary effects, like a detective. The tissue culture dish is our special space badger target, prepared for them to attack, like a mini human body.
A mini human body?
Well, a bit of one.
You put a bit of disconnected human tissue in the dish. Can these results really be extrapolated to actual living human tissue?
Well, actually, we usually use a bit of monkey kidney tissue, to be precise. Special susceptible strains.
If they attack human tissue, why not use human tissue?
Well, it just doesn't work.
What do you mean?
Well, we just can't get the cytopathic effect to happen. You see, space badger attacks are complicated, not easy to see.
But they happen all the time in society.
So we use a special weak line of kidney monkey tissue that shows up the effect clearly. Or we may use some cancerous human tissue. We can occasionally see the effect there.
Surely it should happen at least sometimes with healthy human tissue. Once in a blue moon. Once?
Well, it doesn't, okay? That's not how we do it.
Okay, so if the monkey kidney tissue is so weak, how do you know it's being damaged by space badgers in the gloop rather than just dying? Do you do controls?
Well, we take steps to protect it, you see. We give it a nice sterile environment. We feed it enough bovine fecal serum to keep it alive. Well, first.
I'm sorry, sterile environment?
Yes, we add amphotericin, gentamicin to kill off any bacteria. We always add antibiotics to make sure no bacteria is causing the effect.
Aren't those both nephrotoxic antibiotics known to attack kidney tissue?
Well, you can't have everything.
Okay, you mentioned feeding the tissue, and then you said at first.
Well, we never stop feeding it, really. We just lower the dose to about 5 or 2%.
And what does that do?
Well, it starts to starve. And then we have the space badger gloop, and guess what?
The tissue dies?
Bingo! Proving the existence and pathogenicity of the space badgers. But there's more.
Oh, there'd better be.
You haven't heard the best part. We have pictures.
What's that?
That's the space badger's ship.
How do you know?
Well, look, it's really near a cell that's dying. A spaceship has just invaded, causing it to explode, and you can see it coming out.
But how do you...
I know what you're going to say. It doesn't look much like a spaceship, but you need to understand how the technique of electron micrography works. Let me take you through the process in detail. You'll understand why the spaceships look a little mangled. Okay, you have to kill the cells, the material, take a tiny slice of pellet, mount it in noxious formaldehyde substances, stain them with heavy metals. The microscope can only see the metal staining, not the lighter metal bits or the biological bits. We dry them, irradiate them, slice them really thin, form a vacuum chamber and scatter electron beams at the sample to get an image of the heavy metal staining. Now, naturally, this process has a slight effect on the highly delicate structures, so the pictures are never good.
Actually, that wasn't my problem at all. I'm amazed anything subtle survives the EMG preparation process. I just can't see how any of this at any point, anywhere, in any real data aspect, shows anything whatsoever to suggest space... Hang on a minute, what's that picture?
Now I'm glad you asked. That is an accurate, detailed picture of the measles spaceship.
It's very detailed. It's a lot more detailed than the electron micrography. How come it's so much more detailed?
Modelling.
Modelling?
Yes, we're very proud of our modelling programs.
So that's a model?
Well, it's a model of the real thing.
You said this is a measles spaceship.
Yes, its particular weapons mean it causes the particular damage we scientists call measles.
Is that a measles badger there in the window?
We have no reason to believe there is more than one species of badger, just different types of ships that they fly. I think that's turquoise in the window.
Ooh, you know his name? How can you possibly...
Modelling.
Can you show me another type of spaceship?
Well, the measles spaceship, for example, is very different from the chickenpox spaceship.
Is there any clinical way of differentiating between chickenpox and measles?
Well, there's not really a yes or no answer to that. In the strict clinical sense, there's no way of distinguishing these conditions: measles, smallpox, rubella, chickenpox, monkeypox. But we take into account many other factors.
Like what?
Well, for example, if you've already had measles, then it can't be measles.
And why is that?
What we think is happening is that there's some sort of competition taking place between the different fleets of ships. When a particular type of spaceship successfully invades a human, they leave behind little radiating beacons, a bit like planting a flag at the North Pole. This says to other pilots of that type of spaceship, there's no need to come here, and they try and find somewhere else to plant a flag.
Have you seen or measured output from these radiating beacons that are left behind?
Of course not. They're much smaller than we could possibly see, even with an electron microscope. And they're radiating on quantum frequencies with absolutely no way at all that we...
How do you...
Modelling.
Just a minute, sorry, I'm getting something from my producer. Apparently people have been ringing in, saying that this first picture of the measles spaceship you showed us is actually taken straight from the 1954 founding paper of modern virology by John Enders, in which he supposedly isolated the measles virus for the first time. Are these pictures not from your own experiments?
Supposedly, indeed, viruses. But no, we don't do any experiments ourselves. We don't need to.
Can you explain?
Well, we just use the virus isolation experiments.
I'm sorry?
Oh, yes. See, that's the beauty of it. These papers, these isolation experiments, show the existence of space badgers just as much as they do viruses. When they get their glue from someone with a cough, they say it contains viruses. Actually, it contains space badgers. They think they are isolated viruses, but in fact, they are isolated space badgers. Their experiments are good, but their interpretations are all wrong. Viruses are just a story they made up. At no point is there any evidence any of them exist.
Well, I'm perfectly capable of seeing that, but what makes your claim that it's space badgers any more credible than their claim that it's viruses?
Come on now, I ask you, which of these two do you think is the spaceship? Can you imagine the liability of flying around with all those bits sticking off you? Clearly their modelling is way off. Can you imagine crossing the expanses of space with that? Where's the thrusters? Where are the weapons? Where's the windows? Is it flown by blind space moles? It's laughable. I think we've got to be realistic here. You see, what you've got to understand is that viruses were a product of a mechanistic age. We can trace the evolution of the ideas. In medieval times, it was put down to devils and evil spirits. That's just the way they thought. The name influenza referred to the influence of the stars. Come the dawning of the materialistic age, and they were thought of as little dead but potent bits of poison. And then as we moved into the genetic age, they were seen as sort of alive, sort of dead, little bits of genetic material. You see how the ideas develop with the times. Now we enter the space age, and I think we have to accept those old ideas need to be thrown away. The space badger discovery is very timely.
So, if I can summarize.
By all means, yes. Please, go ahead.
They take the gloop from someone with a cough, add it to these cells which have been poisoned and starved, and the cells die.
Within days.
Okay, what happens if you do exactly the same process with exactly the same tissue culture, antibiotics, and bovine fecal serum levels, but you add the gloop from someone who is well? Or if you had nothing at all?
We don't do that. We can see the damage that the space badgers do, and that's enough.
But that makes no sense.
Look, you ask me why space badgers are the reality and not viruses. Well, there's one glaring reason. Here's something virology can't explain, but we can. Sometimes gloop is added to a tissue culture sample, but we don't reduce the bovine fecal serum to starvation levels. What do you think happens?
The cells never die?
Very good guess. It's a non-intuitive result. You see what that means?
Well, yes, you've made the serum the independent variable and shown that it's reducing this, which kills the tissue.
Are you mad? We have shown clearly that healthy cells must have a way of displaying little pseudo-beacons that fool the badgers into not invading. As the cells starve, their ability to produce these pseudo-beacons is clearly severely compromised.
But
Modeling. Yes, we have detailed blueprints now of all the different spaceships thanks to our metagenomic reverse engineering software.
And these blueprints all turn out the same?
Not at all. These spacecraft are constantly being adapted to produce what we call variants. Remember, they are effectively in a battle zone. 175 measles spaceship experiments last year, and they produced 174 variants plus an original.
So you never got the same results twice?
Of course, no, that's obvious. There's an element of creativity in constructing these blueprints. So there's plenty of wiggle room.
Well, how can you know which is wiggle room, slightly off measuring, assembling, and which is a genuine new variant?
Experience and common sense. If the spaceship is identical, except the coffee cups have a a slightly different design. That's not going to affect the laser cannons now, is it? We have a growing bank of blueprints for all the parts of the ships. So if a hyperspace drive, for example, comes out wrong, we can just insert one from the bank. Sometimes junk comes out of the program. There was a wax kettle in the last run. How would that work? We just cut those bits out. We obviously don't leave an obviously wrong result as is. We're not stupid. We edit it, cut bits, insert bits, change bits as needed. So the blueprint looks like the examples in the bank of blueprints, just like the virologists do.
And these were all made the same way.
That's right.
None of the blueprints were actually reverse engineered from a physical example at any point.
Good luck with that. These things are tiny. How do you propose to reverse engineer a microscopic spaceship with a screwdriver? No, the modelling programs are the way to go and have proved incredibly successful. With a lot of work, we're at the stage now where we are pretty confident we understand all the workings of most of the spaceships. For example, we've established that none of the spaceships ever contain B-days, from which we can conclude logically that all the pilots are male space badgers or working-class female ones. We're beginning to build up a picture of space badger society this way. We know now, for example, that all space badgers, as a species, are allergic to jazz fusion music.
Professor, you're a lunatic.
There are a heck of a lot more just like me in the virology department.
I don't doubt it. Good night.
It's been enormous.